37. The number of bacteria y grows according to the equation dy dt equals ky, where k is a constant, t is measured in minutes. The population doubles every 25 minutes, then the value of k is what? Okay, so we have this little differential equation. We have some information. We don't actually have enough to get the particular solution to the differential equation, but we don't need that. We have enough information to figure out what k has to be. So let's start by looking at this differential equation. We have dy dt is equal to ky, and k is a constant. Whenever I see differential equations, the first thing I check is to see if I can separate variables. Nicest case is I just have a t over here, and that's the only variable, and I can move the dt over there and just take the indefinite integral. It'll be really easy. Not this case, but it's close. I have a y over here, so I want to get all of the t's and dt's on this side, so I'll multiply both sides by dt. So I have dy equals ky dt. And I want all of my y's and dy's on this left-hand side, so I'll divide both sides by y. And I prefer writing it as 1 over y dy. That's easier for me to see what the antiderivative of this will be, but you could just do dy over y. It's the same darn thing, and most books will write it as just dy over y. So it's equal to k being a constant, dt. Next thing, I've separated the variables. All of my y's are here, all of my t's are here, so I'm going to take the indefinite integral of both sides, and I'll deal with the constant at the end, so I'm not going to have a constant on this side, but the indefinite integral of 1 over y dy is going to be the natural log of the absolute value of y. And don't forget that absolute value is actually critically important for some differential equations like this. This one not so much, but some of them it's really important. Alright, the integral of k dt. Don't forget, k is a constant. This isn't the first power and then I go up to the second and divide by 2. K is a constant. I have no t's in here, so the antiderivative of that will just be kt. And I'm going to include the plus c here. And I said, whenever we have an indefinite integral here, we should have a plus c on this side, a plus c on that side, but if I move this over there, one arbitrary constant minus another arbitrary constant is an arbitrary constant, and I get a c in the end. Doesn't matter. Okay, a few things to clean this up. First thing, and actually I might be able to attack this problem now, but let's keep going. Natural log. Let's get rid of the natural log, and I can do that by using both of these sides as powers of e. So I can rewrite this as e to the natural log of the absolute value of y equals e to the kt plus c. And e and the natural log, they sort of cancel out, so I'm left with the absolute value of y on this side. And I can rewrite this as e to the c multiplied by e to the kt. And one more thing before I sort of get rid of this, solve for y. If I have the absolute value, that means that I can have the plus or minus of this side, the positive or the negative. So I could have y equals positive or negative e to the c multiplied by e to the kt. But I don't actually have both at the same time. I only have one. And the way that we always like to simplify this down is this e to some arbitrary constant is another arbitrary constant. It could be positive, it could be negative, okay? Because everything over here, every power of e has to be positive, but this right here says I could have a positive or I could have a negative. And we'll just say, okay, let's make this be some other variable. I'll call it y naught. Okay, the initial y value. Now, I'm not going to go through too much to explain why that's the initial y value. That will take longer than I want to on this problem, but it will be. You could call it a, that's alright. But it will be the starting value. So y equals y naught e to the kt. Okay, here's the trick now. I know this is my initial y value. If you weren't sure, you could put 0 in here and solve for it. It's the initial y value, okay? Basically, what I'm trying to do is figure out what k value, let me get another color, I had to find the value of k that allows me to double every 25 minutes, which means the following, that I will get to twice my initial y value when the time is 25. Okay, let me say that one more time because this is probably the tricky part of this. Doubling, if this is where I start, if when t is 0, that's going to be 1 whole, that's true. It doubles 2 y naughts when time is 25, so k times 25 is 25k. And I need to solve this, so first thing, I can divide out the y naughts, so they actually can both cancel. They won't equal 0, they'll have some value, so I have 2 is equal to e to the 25k. And now I have to cancel out an e to a power, so I can do that by taking the natural log of both sides. And so I will get the natural log of 2 will equal 25k. Okay, if you don't see that right away, what's actually happening is I'm taking the natural log of 2, and I'm saying that's equal to the natural log of e to the 25k. And natural logs and e's, as before, cancel out, so that's how I got that. And one more thing on this, divide both sides by 25, I will get k is equal to the natural log of 2 divided by 25. Now that's exact equality there. These are not exact, and we can get that pretty easily. Just jump to the calculator now. So let's pull this up, and let's see what we have. Okay, so I want to find the natural log of 2, divided by 25. And I can see that it is approximately 0.028. That's great. So let me write that in here. So that's approximately 0.028. And that is answer choice A.